Hello and welcome to my YouTube channel. In this video, I am going to explain what are Eurocodes. Okay, Eurocodes is a comprehensive document which includes steel structure, concrete structure, wood structure and all other structures codes. Here I have got a document which is extracted from that comprehensive code, comprehensive big Eurocode. Basically, Eurocode is a book where you have all types of codes for different structures. For example, this one is only for our beam design or concrete design. Okay, so first of all, we have some formulas, concrete design useful formula. We have these formulas we are going to use in order to design our beam. I am going to use them in my further videos. So let's move on to next page. The next page includes the tables. These tables called C1, C2 and C3. Basically C stand for code. Okay. So first of all we have resistance to fire. This table, whatever data we have, is going to use for resistance of fire against fire, concrete resistance against fire. We have R30, this is a resistance class. We have parameters, minimum breadth, minimum access distance. If you are going to use R30, mean half an hour fire resistance, then your beam has to be with these dimensions, for example. Okay, if you are going to use your concrete or your beam for 30-minute fire resistance, then you have to use this column, for example, and so on. You have 240 minutes resistance against fire for your structural member. So you have to use these dimensions for the beam. Okay, now the second one, we have second beam. This is exposure condition, in which condition your beam is. For example, it's a dry condition, wet condition, or C condition, maybe for example in water, for example moderate humidity, wet, dry, for example. So for that you have to use XC class. This is exposed to air and moisture content, for example, or moisture, for example. So you will have to use from these tables. So we are going to use, I am going to make further videos where I am going to use these all tables one by one. Okay, the next one, we have nominal concrete cover to reinforced for concrete made with OPC, ordinary Portland cement, for 50-year design life. For example, okay, this one, when we design a beam with reinforcement with steel, we have to provide concrete cover so our steel can cover within that beam. So if you are using XC1 class, exposure class, which we have seen in our previous table, then your nominal cover would be 25 millimeters, 30 millimeters. If you are using XC2, then it will be 30, XC4, then it will be again difference, for example. So and so on. We will also use this table while designing our beam. Okay. The next one, next table, we have C4, which is concrete strut capacities. Okay, calculation for shear in beam. This one is FCK and VRD. VRD is basically start condition, your end condition of your beam, where your beam is rested. And FCK is a concrete characteristic strength. For example, this is a formula given for that. If you have your concrete characteristic strength 25 Newton per square millimeter, then you have to use 3.1 VRD, for example, and so on. That's the table, how you can follow that table. Okay, now move on to next table. The next table is minimum shear force in beam, shear force reinforcement, shear reinforcement in beam. Okay, so if your concrete characteristic strength is 25 or 28 or 30, then you will have to use this number, which is minimum area of steel divided by S. Okay, so this is for shear, minimum shear reinforcement in beam. Now the other one, the C6 table, represent area of shear links, area of shear links for divided by S. for various links size spacing. For example, okay, this is bar size, which is H6, H8, H10, H12 and H16. These are the bar size. In Eurocode, they have these bar with H6, or for example, represented with the H. This, if you have a bar H6, the area would be 0.754 millimeter, square millimeter. Then the spacing would be 75 millimeter. For example, if you are using H6 3 bars, then the link spacing would be 75 millimeter each. Links are normally we use to design our reinforcement before pouring the concrete in it, for example. Okay. Now the next one, basic ratio of span effective depth for simply supported beam. So this is basic span and effective depth ratio. If your span and effective depth ratio is 40%, then you will have to use 26.6, for example, basic span effective depth ratio. We are going to use this table in our further videos while designing our beam. Okay. Now the C8 table is modification factor for use with basic ratio for table C7. Okay, it says this table is related to C7. We will also try to use this table also in our further videos. Now the last we have table, these are reinforcement bar size table. These table called reinforcement bar size. This is normally used for beam, and this is used for beam main bars, and this table used for spacing. For example, in when we provide spacing, we have to provide some links, and the links diameter is always smaller than main reinforced bar. For example, bar size is 6 millimeter. Okay, then the area would be number of bar would be this, and the area is going to be 28.3. Let's say we are using 4 bars of 8 millimeter 8 millimeter diameter. Then the area we will take 201. So 201 millimeter square area of steel. So this is area of steel, this is number of bar, and this is the diameter of bar, bar size, and this one are the numbers, how many bars you are going to use in your beam. Similarly, we have bar size diameter, and then these are spacing, how much difference would be from one link to another link.